treatments for example post-harvest quality of tomatoes maintained at different storage temperatures. Tomato is one of the most important vegetable crops grown in Turkey. According to 28 statistical data, 20,150,000 tons of tomatoes are produced in Turkey, which corresponds to approximately 7% of the total world production. Tomato fruits and an important vegetable crops and are among major contributors to carotenoids, phenolics, vitamin C, and small amounts of vitamin E and daily diets. Tomatoes are climacteric fruits and their ripening is highly dependent on ethylene action. The rapid ripening of fruit after harvest limits storability and is a concern during transportation and marketing. Ethylene synthesis and action in tomatoes can be affected by low temperature storage, control or modified atmosphere, and application of ethylene antagonist. Salicylic acid, a phenol compound found in a wide ripe plant species, exhibits a high potential in controlling the post-harvest losses and horticulture crops. Post-harvest assay treatments decrease the ethylene biosynthesis and action, induce the resistance towards disease, prevent oxidative stresses, support the fruit tolerance to chilling injury, decrease desperation rate, delay ripening and senescence, slow down the activity of cell wall degrading enzymes, and mitigate the crop fairness. The objective of the present study was to evaluate the effect of different concentrations of assay and storage temperatures on examining the post-harvest quality attributes of tomatoes during storage. Materials and methods. Tomatoes during the were harvested from commercial field in Cumhuriyet Turkey at being maturity stage using the United States Department of Agriculture tomato ripeness, color classification chart, and immediately transferred to the laboratory of the Department of Horticulture at Selçuk University. Afterwards, fruits were selected for united and freedom from defects and blemishes. Tomatoes were randomly divided into the 4 equal lots. First lot was evaluated as a control group untreated by 3 lots were sent to different concentrations of assay treatments. Each group further divided into 2 lots for different storage temperature. Treated and untreated fruits were stored at 5 centigrade degree for 20 days or 20 centigrade degree for 10 days in open boxes. Fruit quality attributes was evaluated after 1, 2, 4, 7 or 10 days at ambient temperature and 0, 5, 10, 70, 20 days at cold storage. Fruit and attributes: weight loss, fruit firmness, skin color, total soluble solid content, tetratable acidity, SST/TA, glycol content. Weight loss. For both storage conditions, the percentage of weight loss increased during prolonged storage. Control and all CI treatment, while the effects of assay treatments of weight loss was found statistically significant. At the end of the cold storage, the greatest loss in weight occurred in non-treated control tomatoes, while the lowest value was obtained from 1 millimolar assay. As for the tomatoes stored at 20 centigrade degrees, similar weight loss curve was seen with the data of the cold storage findings. Among them, assay treatment and 1 millimolar resulted in the lowest loss weight with the value 4.43%, which was followed by 0.5 millimolar assay. Fruit firmness. Firmness of the fruits gradually decreased during the prolonged storage in both storage conditions. However, all assay tracements significantly maintained the fruit firmness in comparison to control fruits. Initial firmness value of tomatoes were 41, 70, and at end of the cold storage period. The highest firmness value was obtained from 2 millimolar assay treatment, followed by 1 and 0.5 millimolar assay treatments. On the other hand, fruits of control treatments showed the lowest firmness value. Firmness of the tomatoes also underwent a significant decrease during their storage at 20 centigrade degree. At the end of the experiment, firmness values varied 27.7, 25.8, 24.5, and 22.9, and for 2 millimolar assay, 1 millimolar assay, 0.5 millimolar assay, and control respectively. Results indicated 2 millimolar assay treatment significantly softening compared to control. Skin color. Decrease in the fruit skin hue angel value was recorded with the prolonged storage time in both storage conditions, while the difference between treatment were statistically insignificant. At harvest, hue value of fruit skin was 40 into 0.3 degree. At the end of cold storage, the highest hue value obtained from the fruits of the control fruits, while the lowest value was measured in the 2 millimolar assay treated fruits. Hue value of the tomatoes also decreased along with the storage at 20 centigrade degree, similar to cold storage findings. Finally, hue values of fruit skin range from 43.8 degree to 42.5 degree. SSC. In general, SSC underwent a slight insignificant increase through storage. At the harvest, SSC contents of fruits were 4.70%. These values increased during the storage regardless from treatments. At the end of the storage, the highest SSC was observed in control, while the lowest value was recorded in 0.5 millimolar assay. TA values tended to reduce during the cold storage across the applications. TA was 5.117% at harvest, while at the end of the storage range from 0.410% to 473. During the ambient storage conditions, TA also decreased during the storage. The highest TA was observed in 2 millimolar assay, followed by 1 millimolar assay and control, while the least value recorded in 0.5 millimolar assay 10 days. SSC TA. During storage, SSC TA values tended to increase to various levels according to treatment in both storage conditions. SST TA ratio tomatoes 9.10 at harvest. At the end of the 20-day cold storage duration, the highest SST TA value was determined in control fruits, while the lowest ratio was calculated in 2 millimolar assay treated fruits. SSC TA of the tomatoes markedly increased along with the storage 20 centigrade degrees, similar to cold storage findings. After 10 days of storage at 20 degree, SST ratio were 11.91, 11.41, 11.32, and 11.12 for 0.5 millimolar assay control, 1 millimolar CA and 2 millimolar CA respectively. Lycopene. Initial lycopene content of tomatoes was 28.85 milligram kilogram and underwent a remarkable increase due to refining endowment with the great change in control along with the prolonged storage. 2 millimolar assay treatment significantly delayed the initiation of lycopene synthesis during cold storage. During ambient storage condition, lycopene content increased with prolonged storage period. In control and assay treatment, this increase reached maximum level in 10 days. Lycopene varies from 37.19 to 47.18 milligram kilogram at the end of storage. The storability and shelf life of tomatoes are limited due to their perishable texture and accelerated ripening after harvest. Salicylic acid known to be an effective tool in exempting the post-harvest quality of horticultural commodities by preventing synthesis and movement of ethylene was tested at various doses. For effectiveness on post-harvest quality, maintenance of tomatoes stored at 2 different storage conditions. CA treatment at all doses remarkably retarded by loss at both storage conditions. Change in firmness and many other biochemical features were retarded by assay. Among the agreed dose, assay at 2 millimolar can be recommended as it was pioneering for most of the parameters analysis during cold storage at both 5 centigrade degree for 20 days and at 20 centigrade degree for 10 days. Assay treatment may be recommended as an environmental friendly, healthy and sustainable method for extending post-harvest quality of tomatoes cold storage and shelf life without significant adverse effect on producers.